Right, hello lads. So today we're going to have a look at the proof. So I suppose the first proof we're going to have a look at is, I'm just going to make this a bit bigger. Okay, the first proof we're going to have a look at is cos A minus B is equal to cos A cos B minus sine A sine B. Okay, so this is the first proof we're going to have a look at. So in order to do this, we need to kind of visualize something. So imagine a unit circle, okay, and then imagine two radii from the center, okay. Now these radii are of unit 1, and obviously this point and this point will be given by, the cos of an angle and the sine of an angle, and these will be given by the cos of an angle and the sine of an angle. So we put some labels on these to make it easier for when we're looking at it a little bit later. So let's start with the angles. So let's say this angle here from here to here represents A, and then this little one here represents B. So this angle here will be cos A cos B, or sine B sine A. This would be cos B sine B. So this little angle in here is A minus B. This is what we need to kind of get to. So that's our kind of plan. So how we're going to get there, we're going to use two methods. First of all, we're going to find the distance between those 2 points. Okay. And then we're going to equate those distances. So we're going to find, we know that's 1 and that's 1, and we're going to get this angle by finding that distance. Okay, so that's the kind of plan. So let's do it the first way. The first way is obviously using the distance between 2 points, which is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So that's the square root, and that's going to be equal to whatever that is squared. Okay, so that's going to be our plan to get that one. So it's going to be equal to, let's see, x1 is cos A minus cos B squared plus sine A minus sine B to be squared. So that's x1 y1 x2 y2. x2 minus x1 to be squared plus y2 or y2 minus y1 to be squared. Okay, so that's that one done. We're going to square that out. So square the left, square the right, multiply them together and double it. And then the other one is going to be square the left, square the right, multiply them together and double it. Sorry, sine A, sine B. So that's all I've done. So that is that. But what do we know? That's 1. Okay. Cos squared A plus sine squared A is 1. And cos squared A and sine squared A is 2. So 1 and 1 is 2. So look, this pair, I know it should be linear, but this pair, remember there's a plus between that line and that line. This pair, cos squared A plus sine squared A, that's 1. Cos squared B plus sine squared B, that's also 1 minus 2. And then we've got cos A plus cos B plus sine A plus sine B. So that's minus 2 on whatever. Cos A cos B plus sine A sine B. So that's 2 minus 2 cos A cos B sine B. So that's what we've got that now. Okay. So that's equal to the length with the square root. Okay. Now, is there another way of finding that length? Now we've used square root of that formula. The other way of finding that length is using the cosine rule. Okay. The cosine rule says that the length is going to be equal to, what is it, that squared plus that squared minus twice that by the cos of the angle in between it. So it's going to be equal to 1 squared plus 1 squared minus 2 times 1 by 1 by the cos of the angle in between it. That angle in there is a minus b. Okay, so what I'm saying to you there is this length and this length must be the same. So making the two of these equal to each other, making 2 minus 2 cos A cos B plus sine A sine B equal to 2 minus 2 cos A minus B. You can see everything cancels, okay, apart from cos A minus B is equal to cos A cos B plus sine A sine B, which is what we wanted at the start. So that's your first proof done. Okay. So now that you've done it for cos A minus B, you can do the same for any of the other ones. Okay. So let's have a look at the second one. If you want to prove that the cos of A plus B is equal to the cos of A by the cos of B minus the sine of A by the sine of B, you get the formula for the cos of A. All you have to do is, on the previous page, replace the B with a minus B. Okay, so instead of cos A minus B, it'll be cos, I'll show it to you. It's just going to be the cos of A minus B. That makes sense to you. So look, there's the previous formula, A minus B. We're just placing the B with a minus B. Okay, and of course that'll be cos of A minus B. It's going to be equal to the cos of A by the cos of minus B plus the sine of A by the sine of minus B, which is equal to cos of A by the cos of B plus the sine of A multiplied by minus the sine of B. And then, of course, that gives you the cos of A plus B, 2 minus give you a plus, is equal to cos A cos B minus, bring the minus out, sine A sine B. Okay, there's your second proof. Okay, the third proof. So the third one, if you want to prove that the cos of 2A is equal to the cos squared of A minus the sine squared of A, okay, instead of the cos of A plus B, we'll use the cos of A plus A. So the cos of A plus A, so we're using an identity that we've already proven, gives me the cos of A by the cos of A minus the sine of A by the sine of A, which is equal to the cos of 2A, A plus A is 2A, is equal to the cos squared of A minus the sine squared of A, because I can multiply them together. Okay, so they're the kind of easier ones to kind of figure out. So the other identities that you need to know, you have to show that the sine of A plus B. So we do that one. So we've proved that the sine of A plus B is equal to the sine of A by the cos of B plus the sine, plus the cos of A by the sine of B. Okay, so this is one we have to prove as well. Okay, so how do we prove this one? Well, listen, to prove that this one's true, let's start with the one we know. We know that this is true. Cos of A, cos of B, plus the sine of A, sine of B. Okay, so to get this from this, all we have to do is to replace the A with 90 minus A. Okay, now go with me on this. So replace A with 90 minus A. So what will that become? That'll be the cos of 90 minus A minus B is equal to, let's see what that is. That's going to be equal to the cos 90 minus A by the cos of B. Why is it? Because it's a double. It's a cos. Sorry, that's going to be a plus because it's minus. Okay, that minus makes that one a plus. By the cos of B plus. Sorry, I'm running out of space here. The sine of 90 minus A by the sine of B. Okay, so that's going to give me. That's going to give me. Let me see. 90 minus A by the sine of A. That's going to give me the sine of A by the cos of B plus the cos of A by the sine of B. Okay, because 90 minus A is the same as sine of A. Okay, and that's what we want, isn't it? Okay, that's that one done. And we've already proven, I think, in class, this one. Tan of A plus B is equal to tan A plus tan B for 1 plus tan A tan B. Tan of A plus B is the same as the sine of A plus B over the cos of A plus B. And then you're going to expand both of them out, and then it'll cancel down. So let's expand both these out. That's going to be sine A cos B plus cos A sine B over, this one's going to be cos A cos B minus sine A sine B. And then remember, we divide everything by cos A cos B. So divide top and bottom by cos A cos B, and that will derive it into that, because sine over cos gives you tan. Okay, so listen, that's just a quick look at them. Okay, thank you very much. Goodbye.